Welcome to the already fourth ROS-Industrial community meeting. So we're really happy that we're now more than 60 people. So this would be a nice auditory filled. So that's really nice. My name is Ulrich Reiser. I'm from Fraunhofer IPA in Stuttgart, and I have the pleasure today to guide through the community meeting. So we'll have a number of short talks today, I invite you to note all your questions to the chat. So we'll record the chat and then make sure after the talks that we will answer as much as of your question as we can. But we please understand that we cannot have all the questions during the talks. So that's I would say we start in order to stick within the time frame. And the first presentation is from myself. I will give you a short update on the ROS-Industrial Consortium activities in Europe. Then Paul Hvass will do the same for the US Consortium right afterwards. So just very quickly to give you an impression what kind of things we did and we are doing in the consortium. So we typically we're doing workshops at the European Robotics Forum, for example, or at Fraunhofer IPA for the community, the ROS community, but also to involve industry. We're doing also trainings, offering trainings for industry, and also what was an interesting workshop we had in at the IAS in Padua, where we collected ROS related research projects, because there are a lot of projects going on in Europe already. It's not obvious for everybody, for the community, what is developed there. So that was a nice workshop we want to repeat. Then of course we had our kickoff last year in June. We will have more events in the second half. I will tell a bit more at the end of the slides. So what are we focusing in the consortium? So we in one workshop with industry, we collected all the topics, all the issues, requests from industry with regards regarding the usage of the potential usage of ROS in industrial applications. For example, software quality, licensing, certification, and so on. And so we want to handle these questions and also coordinate the work on these questions in the consortium. And in many questions, we are really closely cooperating with the US Consortium. So at the moment, we are starting with model-driven engineering, where we have also a talk later on from Arne. Also, real-time support and standard driver interfaces is something we are focusing in Europe at the moment. In order to tackle these items, we want to conduct so-called strategic projects. So projects that are funded partially by the consortium, but we really want to involve the community into solving these questions, discussing, for example, in special interest groups, organizing workshops, and so on. So it's rather a coordinating activity as we see the strategic projects. So we don't want to solve all closed in the consortium. Yeah, so that was just a really quick introduction, and I want to conclude this short intro with the upcoming activities. So at the beginning of the year, we had we submitted a proposal that has the goal of supporting ROS-Industrial or creating a virtual research environment in the Horizon 2020 infrastructure call. So that's also something we are, of course, targeting from the consortium to involve public money. Today we have the community meeting, and then at the ERF, European Robotics Forum in Vienna, we will have a workshop to organize research and innovation camps for industrial robot software, ROS-Industrial. Here we want to discuss how we can do workshops, maybe 3 or 4 days, and involve industry to gather hands-on experience or feedback to bring together academia and industry in these workshops on the topic. Then we plan our consortium meeting at RoboBusiness. This has to be confirmed, and we'll have our already third ROS-Industrial conference tackling technologies, trends, and markets at IPA in June. Yeah, with this, I'll gladly hand over to Paul Hvass to give an update on the US consortium. Paul, are you there?
Thank you, Ulrich. This is Paul Hvass from Southwest Research Institute in San Antonio, Texas. I'm the program manager for the ROS-Industrial Consortium in the North Americas. Ulrich, are you able to hear me?
Yes.
Good. So let's go to the next slide. So the ROS-Industrial Consortium in America has existed for 2 years so far, and we've grown now to 24 members. You can see the logos there on the left. We're anticipating continued growth. We're excited about that. Our purposes are very similar to those outlined by Ulrich in his slides. We have the things like training, technical support, and then the execution of focused technical projects to extend the capabilities of the open source code for ROS-Industrial. I'd like to bring your attention to a number of events that are coming up for the North American Consortia. First of all, we'll be at Automate 2015. If you're unfamiliar, that is one of the largest trade shows, certainly in North America, for industrial automation. It's held at McCormick Place, which is a large convention center in Chicago, the week of March 23rd. We will have a ROS-Industrial demonstration there at our booth. And in conjunction with that, we'll also be hosting on Thursday and Friday of that week the ROS-Industrial Consortium annual meeting. So we'll have a dinner on the evening of the 26th, and then we'll have approximately a day-long meeting to update you on the activities of the consortium and also to review the upcoming focused technical projects on March 27th. Third event there is our upcoming ROS-Industrial Developers Training. We're fortunate to have gracious hosts in Caterpillar, also in Illinois. We have an Illinois theme going on here. So they're in Peoria, and that will be April 29th through May 2nd, and indeed that goes through Saturday. So if you're planning, we'll have a tractor assembly line tour starting on Wednesday afternoon, and then training the next 3 days in kind of various ROS-Industrial developer skills. The last thing I'd like to mention is that we have ratified a dual membership. So if you are a full member of either the North Americas Consortium or the European Consortium, you have gained reciprocity with the sister consortium and can participate in activities and also in focused technical projects. If you're interested in more of the kind of details about that, feel free to contact either myself or Ulrich. And with that, here's my contact information, and I turn it over to Uli.
Yeah, thank you very much for your update. I'd like to continue with Dejan Pangacic from Bosch, because he has to leave a little bit earlier. Dejan, are you here?
I'm here. Can you hear me?
Yes, I can hear you. So Dejan is a research scientist at Bosch, and he's also involved in the organization of the Amazon Picking Challenge, and so we have some slides on an update of the Picking Challenge from Dejan.
Yeah. So hi, hello everyone. First, I apologize upfront. It's my vacation week, and I'm actually logging in from one Starbucks somewhere close to Times Square in New York. Not optimal conditions, but I hope that you guys hear me. If not, just interrupt me, and maybe my colleague Arne can jump in. As Ulrich said, already he asked me to provide some update on that on this picking challenge that Amazon is organizing. So if we go to the slide number 2 with the information in a nutshell, the challenge is, as I said, organized by Amazon, basically by Hvass, which has been acquired by Amazon. And the main organizers, the main guys running the show are Joe Romano and PW from Hvass. Then there is a couple of guys, including me, basically sitting in the so-called steering committee, and we're actually helping out with advices and some minor tasks. So most of the information is available on AmazonPickingChallenge.org. You can write to Joe Romano himself, or you can also write to me, and then I will just relay. At this point of the challenge, there are basically 2 most important active deadlines, so to say. One is mid of March, which is the deadline for the travel support and for the content enrollment deadline. So basically, if you want to actively participate in the challenge, then you should let us know. Should submit basically a video application demonstrating that you have achieved or you're able to achieve part of the picking challenge, and then we'll let you know whether you have been accepted or not. The actual competition will take place during ICRA, or basically at the same time as ICRA, and we'll also be collocated with ICRA which will take place in Seattle. So May 26 to May 28. The main motivation for the challenge is basically to bring true mobile manipulation in the industrial setting, in the actual industrial setting. So the example that I will talk about later a little bit it is actually an actual setting that Hvass or Amazon is having. There is also a prize and travel support. So basically, first 3 teams will split between them $26,000, and there is $45,000 available as a travel support for the teams willing to travel to the challenge and bring their own equipment. Last week we had a deadline basically for the equipment application. So basically, Amazon will provide a shelf and items. And as of last deadline, basically there was 30 teams that applied for it and that are actually actively working towards participating in the challenge. If we go to the slide number 3, a little bit about the contents details. So basically, on the right-hand side, you see a picture of the Amazon shelf. So this is an actual shelf from their warehouse. at the checkout station, and basically the challenge will be to actually get the items which are placed in the bins in the shelf out of the bins, and basically then in some box that will be located in the near proximity of the robot. So robots will have to pick objects out of the bins marked with the letters from A to L. They will have an area of about 2 times 2 meters in front of the shelf to operate in. Objects will range in different shapes and sizes. A little bit more about it on the next slide. And only the single face, the front face of the shelf, will be presented to the robot. Each bin can contain 1 or more items, and then, as I said, they have to be placed in the box next to it. So this is basically the major objective of the challenge. If we go to the slide number 4, so Amazon put together basically a list of 27 items, the best-selling items, so to say, that robots will have to, or the contestants will actually have to pick up. From these 27 items, 12 will be selected randomly and then basically put in the bins. Some bins will have 1, some bins 2, some bins 3 items. Berkeley, with Peter Wilslab, has been actually very hard at work already building the models for these objects. So if you are about, if you're thinking about how to take part in the challenge, then you can actually navigate to the link provided and actually download very detailed models of the objects. Otherwise, for the actual challenge, every team will be actually 10 minutes before the start of the task will be given a so-called JSON file, configuration file, which will basically tell where the objects are and which objects the robot is supposed to pick up out of the bin. Each team will have 20 minutes for the task, so to basically pick up 12 objects off the shelf and put them in the box. And we will not allow any human interaction. So the robot actually has to be fully autonomous. And as I said, the objects that are to be picked from the bin are on the right-hand side of the slide, are depicted in the image on the right-hand side. If we go to the next slide, slide number 5, some companies have been basically nice enough to provide their platforms on-site. Rethink, ClearPath, Olympus Controls, Yaskawa, and Fanuc would be the 5 robots that we will have already on-site. But participants are basically. Oh, I'm sorry. I think I actually skipped one slide. Never mind. So I'm talking about slide number 6 right now. So there will be 5 different robots that will be already on site, but participants are of course encouraged to bring their own equipment also if they want. I skipped one slide, as I said. That slide was basically about the scoring. So if you maybe move back to slide number 5. Basically, as you see in the scoring sheet, we basically reward all the successfully picked items. The ones that are picked up from the bins with more items are rewarded more. And of course, we penalize all the malicious actions. So basically, if the items get damaged or if the items get dropped from the firm grasp or from the robot hand and so on. And as I said already before, first 3 teams will get the prize. On the slide number 6, there is also a link for the registration. So if you want to do that, if you want to participate, please navigate there and register. As I said, the deadline is mid of March, so it's a little bit tight, but there is definitely still some time if you want to participate. In terms of ROS-I, so ROS-Industrial Consortium participation. As I said, I think the contestants would definitely benefit from maybe having even more robots on site that they could use, or of course robust vision, motion manipulation, or grasping calculators. We, basically the organizers, are but definitely also looking to basically identify possible partners and then try to suggest them to enroll into ROS-Industrial Consortium as well. So that would be from my side. If there are any questions, I'm happy to answer them either now or also later offline. My contact information is on the last slide.
Thank you very much for the presentation. Thank you very much for your presentation. I think I don't see any immediate questions on the chat. So yeah, if there is anything we can answer later, just let us know. Yeah, we are looking, of course, with interest from the consortium on this very interesting application of the Amazon Picking Challenge, and really look at the what is coming out, and certainly ROS will be intensively used for this challenge. Now it's a pleasure for me to introduce the next speaker, Shaun. Probably everyone knows him as the founder of ROS-Industrial. He's with the Southwest Research Institute, and he will present one result of one focus technical project. Shaun, it's your you have the mic.
Okay. Can you hear me okay?
Yes, I can hear you.
Okay. Thank you very much for that kind introduction. So what I'm going to do is take about 10 minutes and describe to you a ROS-Industrial project called Descartes that we've been working on. Just give you some background on it and let you know where we are and where you can find the source code, because that's what this is really all about. So first I'll start off with what the application need is that we see in industrial applications. It's really about path planning, and it's different than your traditional path planning that you do in ROS with a package like MoveIt. In MoveIt, it's very focused on pick and place and kind of free space path planning. In the industrial world, we have those problems, as you can see with the Amazon Picking Challenge, but we also have a lot of problems where we know generally the path the robot has to take because it's doing some process. But that path is somewhat fuzzy. We call them semi-constrained trajectories. And the definition of that is when your trajectory has fewer degrees of freedom than your robot. So there's some redundancy built into your system. Good examples are grinding and painting, welding. In those particular applications, the orientation of the robot tool and the process it's performing has some wiggle room in it, and tolerance associated with it. So it's not purely a 6 degree of freedom pose that you want, but it might be 5 or 4.5. Other examples like deburring and 3D printing, where you basically have an axisymmetric tool with which you can rotate around and still perform the process. So that's a 5 degree of freedom problem. And of course you have redundant robots where even if you have a 6 degree of freedom pose, you have extra joints which you can utilize to position the robot in different poses. Next. So the current solution to this problem, if we were using off-the-shelf tools, and there are tools for this, is pretty much an arbitrary assignment of 6 degree of freedom poses and redundant axes. So even though you may have a 5 DOF requirement, in order to get a robot to perform it, you have to specify all 6. And these really give you limited guarantees on your trajectory timing. For a process like robotic machining, you might want a certain feed rate, and if you pick the wrong pose, the robot may not actually be able to achieve that feed rate. It also results in reduced workspaces. So if you have to maintain a certain orientation, it can result in a kind of shrinkage of the true workspace of the robot. And these processes, this arbitrary selection of 6 off poses, really relies on human intuition about the robot kinematics themselves, which is very, very difficult. And when that human intuition fails, you end up with collisions in the workspace. You end up with robots approaching singularities and running into joint limits for these really complex Cartesian paths that we're trying to solve. Next. So we started the Descartes project to address these problems. In short, what Descartes does is it's a planning library for semi-constrained trajectories. At a high level, the requirements that we had for this project were to first generate common sense plans. And this is kind of ambiguous, but what it really means is we want to generate plans with the Descartes planner that look like plans people would have generated themselves. A lot of you may be familiar with kind of the random sampling and the kind of random path plans that come out of that. And while that's required for kind of pick and place applications, we felt we could get better plans given the constrained trajectories we have to deal with. We also had a requirement that we be able to find easy solutions fast, but also be able to find hard solutions given enough time. So our methods and our planners had to scale to the complexity of the problem. We also had to handle hybrid trajectories. So trajectories that include joint waypoints, Cartesian waypoints, and even specialized waypoints that may be specific to a process like painting or grinding or welding. And then finally, we wanted to be able to do fast replanning or cached planning so that if minor modifications were made to the plan, we could very quickly replan without having to start from scratch. Thanks. So we're about midway through this software project or the development on this project, but we already have one application example under our belts. We call it robotic routing, similar to robotic machining, but we're cutting parts out of thin sheet metal using a router. As you can see in the images there's a reasonably complex path that represents the outline of a part we'd like to route. And on the right, we're using a very large, very stout, sturdy KUKA robot to perform this robot routing task. The trajectory can really come from any kind of source. It could be scanned, it could be coming from CAD, but that's the input to the Descartes planners, is a semi-constrained trajectory in space. Next. So given this first application that we tried, we've been able to achieve 800 5-degree of freedom waypoints planning in 30 seconds, which is good for this application. It's an offline planning application, so there was no real-time requirement. And it's a reasonably complex path, which kind of moves in full 3D space with large orientation changes. So we're proud of that performance. We think we can do better, but we're proud of it as it stands. The current path planners have to minimize something or optimize something. They currently just work on minimizing joint motion while adhering to all the trajectory constraints. Replanning, we've been able to achieve as near instantaneous. So when changes are made to the trajectory, they happen almost instantly. And we do have support for hybrid kinematic path planning at this point. We're working on getting full full trajectory or timing built into our planners in the last half of the project. And if I can, I'd like to show a video, a YouTube video.
I don't think that's going to work.
Oh, it's not going to work?
I don't think so.
All right.
That's not.
Okay. My bad. I forgot to warn everybody. But if you look at that video, you'll see a.
Can we paste it into the chat? That way people can watch it.
So if you look at that video, what you'll see is our path planner working on that path that I showed in the previous slide, and also showing kind of the human interaction going on that allows a person working an offline planner to adjust the path as they need. Again, giving us that instantaneous replanning. Okay. Next. Okay. So where we are, we're doing all of our development out in public, so everybody can see our pull requests, all the reviews that are going on, every commit that we're doing, which is both good and embarrassing sometimes. But we like you all to come see what we're doing. We expect a ROS-Industrial release of Descartes in the second quarter of 2015. In the video, you'll see a really nice GUI that sits on top of Descartes. We'd like to release that open source, and we're working towards it, but we don't have a date for that release. And finally, I'd like to acknowledge all the people that helped on this project. The developer team includes Dan Solomon, who was formerly with Southwest Research, myself, Jorge Nicho, and Purser Sturgeon, all with Southwest Research. And also, this project was supported by NIST funding and ROS-Industrial Consortium funding as well. And we appreciate their support. And that's me, photoshopped very well. But feel free to reach out if you have any questions or are interested in Descartes in any way. I'm happy to talk to you more.
Yeah, thank you, Shaun, for the really interesting presentation. If anyone has questions, please paste it to the chat board, and we can answer them at the end of all talks. Now I'd like to introduce the next speaker, Arne Hamann from Bosch Corporate Research, Systems and Software Engineering Group. And he will present first strategic projects proposal from the European Consortium. Arne?
Exactly. Yes.
Okay, I can hear you. Yes.
Okay, great. I'm also on the cell phone. So I didn't have other choice, but I hope the audio quality is okay for you. So yes, we are currently in the setup of the European Consortium, bringing in the first proposals, and we are, let's say, I'm not a robotic specialist, so I'm more coming from the embedded domain and real-time systems domain, and what is the classical business of Bosch. So this is where I was working last year, and there's a lot of modeling tools where you try to increase your efficiency and just say not writing C code, but having, let's say, some more abstract notions, modeling notions that help you to compose your system out of different subcomponents. And when we first looked into ROS, and we were somehow surprised that there's very little modeling abstraction. Basically, you have to take care about each and every interaction between different nodes manually in the code. And so what we would like to introduce, and we see there's a good chance to do so on the upcoming ROS 2.0. There will be a talk later from Dirk, I think. Since there's DDS, and DDS, let's say, gives you some more control about quality of service. This is how this is called, and we would like to start a project and involve also many of you people who are also interested in this phone call. Not only partners in this consortium, but also external research institutes. For instance, we are in contact with Ulm, Hochschule Ulm, with Professor Schlegel and Alex Lotz. and to see what we can achieve with this QoS in DDS. And yes, I think I have control over the slides. No, first of all, I mean, for you, to motivate, I've copied in some pictures about DDS. You see that also basically it's a blackboard, classical blackboard, but you have this DDS to do the communication with publish, subscribe, and the important thing is that you have on this topic you can configure a lot of QoS properties. And okay, let's move to the next slide. And basically, what you do, you control. So there's no physical presence of any topics in DDS in between writers and readers. So each writer and reader has a queue. And basically, what DDS does is controlling the buffers. So buffer sizes, you can reason about time on the buffers. So jitters, how they arrive, some lifetime, the garbage collection when data packages are collected, and also some persistency and consistency of data among different endpoints. And just to give you a glance, I mean the configuration space of DDS is huge, and I mean this is let's say a little bit the motivation of this strategic proposal, to see what is useful there and how we have to configure it. Because when you look at these different QoS examples, there are different aspects. So one thing is, for example, this data availability. You can associate a topic with a lifespan. You can say, okay, it's volatile. That means late joining, let's say, consumers of this topic, they cannot access, let's say, the history. But if you say it's transient, local, then you can, even a late joining consumer can read the history of course, then bounded by the lifespan of this topic. And if it's persistent, you can even, let's say, restart the system and you will find your data. So this is just one possibility, and there's a lot of parameters only to attach to this quality of service. Then you have also these, let's say, real-time or this, real-time related or timing related QoS that you can specify the throughput, or this is at least the standard, let's say, proposes that it should be possible to, let's say, to traffic shape somehow, to limit the throughput of some based on some time-based filters. And of course, there you see, and then again, it depends on the implementation. I think not all the DDS implementation out there are currently supporting this feature. Then you might want to specify latency budgets or deadlines, or configure the priority of a transport of a different topic. And basically, the conclusion when we looked together with the guys at Ulm at all these different configuration, let's say, forest, see that, I mean, here just to give you an idea, you can attach QoS to many different places in this DDS world, and I think the message I want just to give, yes, you can achieve a lot of things with this when you do it right, but it's very difficult to understand and to use. So I don't think that it's a good idea to let access every developer to these QoS parameters. And at the same time, also when you hide them, the question is, and I think this is on the next slide, what are the really useful modeling concepts that we need or that we would like to have for robotic systems that we can realizing once there will be DDS and ROS 2.0. It's a question. I mean, of course, we could configure DDS so that the system behaves just like ROS behaved all the time before, but there might be some more possibilities that we would like to offer out of the box for developers of robotic systems. For example, if I have critical paths that I constrain end-to-end latency, that I constrain the jitter of some messages, that I constructively using DDS, or that I synchronize data streams, perhaps also on a time basis. Then it's the question, okay, how do we map these modeling concepts to QoS parameters consistently, because it's a system-wide configuration. I think it's not, for many things, it's not only the configuration at a single point in the system, but you have to configure somehow several nodes consistently. Then, especially for the temporal QoS topics, then you have to also to go through to the OS, you need to configure the scheduler. Currently, this is completely neglected, so it's just happening. Scheduling and let's say processor sharing is just happening, and also let's say RTI and PrismTech, they somehow delegate this problem and say, okay, this is not our issue. You have to know your system, and you need to be sure that everything is real time. But I think this is only part of the answer. And the goal would be really to contribute, let's say, some in which form this has to be done. I think this has to be discussed with OSRF. Hopefully we can convince them to join such a strategic proposal. And currently committed to partners is ourselves at Bosch and also Fraunhofer IPA with Alex, I think. Okay. Again, this is a slide showing showing the picture of the person speaking. And yes, contact me or the guy from IPA if you are, so Ulrich or Alex, if you are interested in this kind of activity. And of course, I'm happy also after the meeting to discuss on this if there are some questions.
Yeah, thank you very much, Arne, for this interesting talk. So if there's anybody who wonders what DDS is, now Dirk Thomas will tell a bit more about it. And
we should have said inverse.
Maybe we should have switched the presentation, but anyway, I think it's connected, these two talks. And so I'm happy to introduce Dirk from OSRF, Dirk Thomas, who is the architect of ROS 2.0. I hand over to you, Dirk.
Okay, thank you very much. So I'm Dirk Thomas. I'm working for the Open Source Robotics Foundation. And as you know, we're doing most of the development on the core ROS system, basically, and maintain all of the infrastructure. Can you go to the next slide, please? Or can I operate it myself? Okay, so you've probably seen this slide in a lot of presentations already. The part of ROS is like not only the middleware part of funding to make like the communication work, but there's all the tooling, the capabilities, and especially the ecosystem around, which makes ROS like as successful as it currently is. But there are things in the lower level, like in the communication protocol, the plumbing basically, which is already like several years old. And when ROS was developed in the first place, there was not really very good alternatives available. So a lot of the protocols for communication have been developed from scratch. And that's something which now with like 7 years old ROS system, we consider to revamp, to rethink, and actually consider using not new development again, but looking into existing solutions and finding a very well established standard to not have to reinvent the wheel again. And after a lot of research, basically, go to slide 3, please. There are like several use cases where ROS currently falls short. So if you think about running ROS on a very small, like bare metal microcontroller, you basically face the problem that the whole protocol design using XML, for example, is not well suited for these like very minimal systems. Also, in scenarios with like real-time control, the ROS scheduling, the threading, how you handle callbacks, etc., is not meant to be real-time safe. And there are ways to interoperate with like Oracles to perform real-time tasks, but there could be a way better integration to keep it more, to keep it closer to the ROS system, basically. Also, the slide doesn't come very well. There are some pictures missing, I see. If you think about multi-robot system, as soon as it gets to wireless connections, usually the protocol using TCP does not work well. UDP is not very well supported by all client libraries in ROS. And if you have then unreliable networks, basically the underlying middleware is not capable of giving you the functionality reliable enough to build really good multi-robot applications, I would say. And another complaint we hear, especially from partners which work in the industrial area or try to build products on top of ROS, is that they usually use ROS for prototyping because it works really well. But as soon as they get to the point that they actually want to sell a product, they throw away the prototype and redevelop it from scratch in order to fulfill their like more strict constraints, for example, on the code, on checkability, on code quality, etc. So this is also something which I think picking an already solid standard will hopefully resolve that people can actually trust the underlying system more. So after a lot of research, we came to the conclusion that DDS, the Data Distribution Service, seems to be the most appropriate standard for the next generation of ROS. And DDS is an industry standard which is already like 10 years old. It's coming from the OMG. They brought up CODA before, but people are usually a little bit hesitant if they hear about that. But the DDS standard is very actively developed. It's not like a standard which has been written once and not updated. So there are like even nowadays, like every year, there are new proposals to enhance functionalities, features, etc. So it's very actively pushed forward. The middleware itself is peer-to-peer, so it doesn't have a central broker. And as we heard in the previous presentation, it has a lot of configuration options for quality of service, where quality of service can mean a lot of things in DDS. And it's able to handle various network situations. And it handles them way better than the ROS-I protocol, because it's just meant for a much bigger applications. The protocol itself is real-time capable, so if you have control over the network, you can achieve like predictable communication time between multiple nodes. There are several implementations of DDS, roughly 12, could be more by now. Some of them are commercial, some of them are open source implementations. As we've heard in the previous slide already, the most known ones are from RTI Connect and from TwinOaks Cordiac and PrismTech OpenSplice. I think what's not on this slide, sorry, probably an open office conversion layout problem. DDS is used in a lot of industrial applications. So it is actually used on, I would say, mission-critical applications. So, for example, trains or dams or ships. And there are versions, which are usually obviously commercial, which are DoD verified, so they can be used in like flight systems, for example. Also, some of the vendors offer very, very small footprint solutions, so they can actually work well on small embedded devices. I don't want to go into too much detail about the DDS functionality, because that can easily take like more like 10 hours rather than 10 minutes. But since there are various vendors out there, RTI, RTI Connect, OpenSplice version, Cordiac, we don't want to make the decision to lock you into one specific vendor. So we spent quite some time making our prototypes work with different vendors, and that it is easy in the future to add more vendors. So if you happen to have a commercial license with one of them, that's great. You should be able to pick them. If you rather want to use an open source version of DDS, you should also be able to just link against that version, and ROS should work on it. And since DDS is a standard, which also basically standardizes the wire protocol, there should be no issue in communicating between vendors. There can be problems we found in prototyping, but usually the vendors work hard to make their systems interoperable. So what have we got so far? We have developed prototypes for ROS-II, which currently contain publish subscribe and some asynchronous and synchronous service calls. There still needs to be done parameters and the component lifecycle, which should be the set of functionalities we aim for the first release. And the current plan is to have a version of ROS-2, which doesn't have a code name yet, as at the same time as ROS-1 Jade Turtle, which comes out in May this year. That's pretty ambitious, but at that point we hopefully can deliver a solid foundation that will not replace your ROS-1 system yet, but it should demonstrate all the advantages for the communication protocol, and should definitely show the developers the features they can expect from ROS-2 and how these will definitely show more capability than ROS-1 systems. The most asked questions is usually regarding compatibility, and what should definitely be supported is that a ROS-1 system can talk on the network with a ROS-2 system. That's something which should be fairly straightforward to achieve. We are also looking into having API shims on top of ROS-2, which give you a ROS-1-like API, but that will be something we have to evaluate how solid it is and how well it can be used. Since this slide cuts off some of the links, would be interesting if you want to look into that one further. I will post them to the chat after this slide. If you have any further questions for that one, you can of course email me, but there are also mailing lists, or for example the GitHub project where you can just fill a question there to get further information and keep the discussion public as possible. Thank you very much, and I guess there might be some questions.
Thank you very much, Dirk. There's seems to be one quick question about OpenDDS. Is that also supported?
We currently do not have like an implementation of that. We have basically an interface which every vendor, on top of every vendor, we have to implement in order to work with ROS. And for OpenDDS, we haven't implemented that library basically, which is usually not that much effort. I would say for one vendor it should be far less than a week of work. For OpenDDS, we haven't done that because the OpenSplice, Cortex, and Connex were the three most, let's say, the most solid implementations of the DDS standard by now. But I think OpenDDS should be not very difficult to integrate. One of the issues why we keep the number of vendors currently smaller is due to the fact that every feature we develop in the prototyping we have to carry forward for N vendors. And some of the implementations do not yet support new things in DDS, like the service specification, which is just being ratified like currently, basically. So it's not implemented by a lot of vendors. So we try to keep the set small until we get to a reasonably high feature set, and then we can add more vendors.
Okay, thank you very much. Then we already come to our last speaker for the talk session, which is Sachin Chitta. He is Associate Director of the Robotic Systems and Software Department of Stanford Research, SwRI. And Sachin, it's a pleasure for me to hand over to you. It's the talk is obviously about MoveIt. Sachin, are you there? So Sachin seems to be online and unmuted, but no, I cannot hear you at the moment. Okay, maybe you try to call via phone. Maybe then we have the possibility to give one more question for Dirk. So I think Arne has already said that there's the question if OSRF would be able to join the project about modeling CDS QoS functionality. What do you think, Dirk?
We would definitely be interested to be involved in like the discussion and to learn more about that. The question will be how much we'll be able to contribute, since we are still like working heavily on the lower part, on the lower level, I would say, to get us a working ROS core system. There might not be much resources, which I would predict, but it would definitely be interested to be involved in the discussion and to learn more on how we can model that, and also how to make it like easy for the user to actually choose between reasonable configurations, because yeah, the average user will hopefully only see a very, very small set of these QoS parameters.
I mean, that's the goal, huh? I mean, I'm basically I think it's also the discussion part is the most important, huh? When we say, okay, how do we want, which kind of modeling, let's say, primitives do we want to offer a user? And I think that because I had, let's say, several stages, and how the implementation is then afterwards done, or I mean this is anyway an open project. We can always see who can do it. I mean, the conceptual work is the most important that we want to cover in this proposal.
Yeah, let's talk about that as a follow-up. That sounds like definitely interesting.
Great. So we have an update of Sachin, but unfortunately he's not able to. Sachin, are you here? No. Yeah. So we give some more minutes to try other options. Do we have any other questions so far to any of the talks? So I think we covered all the questions already in the chat. But maybe there's some new questions. Okay, that doesn't seem to be the case. Then okay, we have one more. We have one more question to DDF from Ian McAhan from Boston. Is it required to have a real-time kernel to run DDF?
No, so you can run DDF as a non-real-time system on a normal system. So we're doing most of the development on an Ubuntu system. But if you want to run certain processes or nodes at the end with real-time constraints, then of course you want to run a real-time kernel, because only that will guarantee you the scheduling, etc., which you actually demand for certain processes.
Okay, thank you. And now we have some more questions. I think that's a question for Paul, maybe, from Glenn Saunders. Are logistics for Automate meeting already finalized? I think Paul is currently trying to. Yes?
Sachin was just trying to call in. I think we're going to focus our attention on getting him conferenced in. It'll be just a moment.
Yeah, okay, sure. So maybe we take the next question. This is for Dejan, I think. So Dejan, are you still there? I know that he had to leave a little bit earlier. So the question is about the application for the Amazon challenge, and if it's still possible to apply. I think we have to answer this question offline, so we can we record all the questions, and yeah, we can handle them also offline to hand over it to data. Hello?
Hello?
Hey.
Oh.
Hey.
Okay, technology works. Hello, Sachin. Good to hear you.
Hi, can you everyone hear me now?
Yes.
Yes, now it's fine.
Okay, now I'll hand over to you.
Okay. Thanks a lot, guys, for having me on this call. I'm going to present an update about MoveIt, mostly about where it is right now in terms of users and kind of the status of it. So if you look at MoveIt usage, it definitely has increased by a huge amount over the last couple of years. These are statistics that I pulled straight from Google Analytics for the MoveIt.ros.org page. This is only for January of this year, and just from the number of page views, it seems like there's a lot of usage and lots of people getting onto the website to get information. Also, from looking at kind of the list of pages that people are looking at, I picked out just the number of visits to the install page, and kind of took that as a representation for how many times people were installing the packages. I know there's a better way to get metrics directly, and I'll coordinate with OSRF on getting those the next time. But it's clear that there's probably in the thousands of installs happening every month, which is a good sign for the community, the growth of the community. Going on to the next stats page, so in end of 2013, there were about 177 people on the mailing list. Today, there's over 500. Like I mentioned, the stats for the number of installs, I just used the number of visits to the install page. There's more and more robots that are using MoveIt. It seems like every new robot that comes out starts using MoveIt right away, or tends to ship with MoveIt right away. And also, OSRF had conducted a survey last year asking people what they thought the most important components of ROS or the capabilities that they were interested in. And MoveIt was ranked right up there. So number one was the ROS visualizer, and after that the navigation stack, and MoveIt was number 3. So if we go to the next slide, recently we had more people starting to help out. In particular, I should mention Mike Ferguson, who has been handling the regular maintenance of MoveIt. So he was instrumental in releasing a separate version of MoveIt for ROS Indigo, and covering a lot of pull requests over the last month or so. We've got tons of bug fixes, mostly based on community contributions, and I've listed a bunch of people that contributed. If I missed anyone, I apologize. I'm sure I've missed a few names out there. But there's a wide variety of users out there, everything from academic to people in commercial companies who are contributing back bug fixes, which is helping in terms of keeping MoveIt up to date and kind of making sure that MoveIt is responding to the needs of the community. There's a lot of new capabilities, quite a few of which have come from the efforts of the ROS-Industrial Consortium. So there's the Cartesian Path Planner plugin, which was based on effort coming out of SwRI from an intern who was there. There's a new trajectory display, which is basically a port of the trajectory display capabilities in the motion planning plugin. This came out of from Dave Coleman at Colorado. There's trajectory velocity scaling capabilities, which now allows you to specify or to scale down the speed at which you want the trajectories to be executed. And that came from one of the teams in the DARPA Robotics Challenge. So Stefan is from Team Reiser. There is a joystick interface that lets you interact with the start and goal markers, and that came from JSK, from Rohei Ueda from JSK in Japan. And then there's a plug-in interface so that you can plug in new collision detection algorithms, and that came from Mike Ferguson here in the US. There's a lot of new robots that are coming out with MoveIt interfaces, and I've put just a few that I know about. I compiled this list mostly from people either sending me emails or from just looking at community involvement or the mailing list or on GitHub. So Polly is a robot from SwRI Karlsruhe. Tiago is a robot that was just recently released, just this week, from HAL Robotics. Taurus is actually one of the robots here at SRI International. It's a two-armed dexterous robot, and we put MoveIt on it. And the ROS-Industrial Consortium put out drivers for the two-arm Yasukawa SDA TANF robot, and some impressive demos with that as well. We're seeing a lot of interest in applications, especially we've seen a lot of teams in the DARPA Robotics Challenge use MoveIt. So there were a few users last year, although last year the challenge was mostly teleoperated. This year we expect to see more users using MoveIt because they've changed the rules and are emphasizing more autonomous behavior, basically by cutting down or cutting off the bandwidth from time to time in the challenge. So we expect to see a lot more people. We know, for example, that Team Reiser is already using MoveIt, but we expect to see a lot more use because this is the kind of application that MoveIt was designed for, which is more autonomous use in unstructured environments. The other application that we've seen a lot is pick and place kind of applications, and again, a majority of these applications come from the ROS-Industrial Consortium. So there's a couple of movies that you can see on the ROS-Industrial blog of industrial pick and place applications. One with the UR5 robot, and also with the Motorman two-arm robot. We also saw another really interesting application from Alton Mechatronics, again part of the ROS-Industrial effort, for path planning, for essentially a TEM, and that I thought was a unique use of the path planning capabilities in MoveIt. That it's the kind of application we haven't seen before. There's a bunch of upcoming events, mostly on the research side, where we expect again to see robots running MoveIt, and I highlighted two of them. One is the DARPA Robotics Challenge, which is happening in June 5th and 6th in California, and then there's the Amazon Picking Challenge, which Dayan already talked about, happening with ICRA in Seattle. So in both of these challenges, there's an emphasis on autonomy, there's an emphasis on speed, and there's a lack of structure in the environments that participants have to deal with. And these are all ideal use cases for the capabilities that MoveIt provides. The last slide is contact information. If you are releasing a new robot or you're using MoveIt with a new robot, I would love to hear from you. If you want your robot up on the MoveIt blog, I would love to hear from you as well. So any interesting applications that you might be putting out, we would love to hear from you and put those up on the blog as use cases for MoveIt. Thank you.
Yeah, thank you very much, Sachin, for your nice overview on MoveIt and how it's being used. Do we have any questions to Sachin's talk? So on the chat, I saw some kudos and some links on the videos you mentioned. But are there new questions? So there's one coming up from Michael Francis. Could you talk more about the new capability for MoveIt and the trajectory velocity scaling functionality? And whether it's for Hydro or which version of ROS?
A lot of the new capabilities right now are going out mostly for Indigo. We haven't backported them mainly because of we haven't had the time. If the capability for trajectory velocity scaling is actually it's fairly simple, but it does involve a change in one of the messages, and we probably won't break. We're not supposed to break Indigo either, but we released the new message. I don't think we'll go back and do it for Hydro though. Does that answer your question, or?
Maybe the question also was a little bit more on, to go a little bit deeper on the trajectory, the velocity scaling.
Yeah. So if you look at how MoveIt right now plans its path, there is a set of velocity and acceleration limits that it can read directly from the URDF. And one of the needs was for the robot not to go as fast as possible, but have the ability to scale the velocities of the planned trajectories, but on the fly. And the way that's been implemented right now, it's a single scaling factor that you can specify directly on a per motion plan basis. And internally, what it does is just scale down all the maximum velocities. So right now, it's only for the maximum velocities. When it's doing this, the trajectory parameterization, it will scale down the maximum velocities by that scaling factor. the scaling factor defaults to 1. So if you don't specify anything, it'll always just default to the previous behavior. But if you specify an actual value, then you can have a behavior where it'll slow down the entire trajectory based on what you specify.
Okay, thanks. There's another question related to that from Andreas Runefugel, I guess from Denmark. The trajectory monitoring is currently using the URDF parameters. Are there any plans for using the actual velocity instead from joint states, for example?
I'm not sure which part he's talking about. Is it the trajectory? If it's the trajectory scaling, it uses the URDF velocity acceleration, but you can override those with parameters in a YAML file. I don't know. So the trajectory monitoring itself monitors the execution of the trajectory. So it's not using the velocity scaling as such. So I might be reading this question wrong.
Okay, Andreas, did that answer your question?
I think, yeah. Andreas, if you can send me a more detailed question, I should be able to answer that.
Yeah. So do we have any more questions? Also to any other to the other talks? So maybe one more question to you, Sachin. As I understood, then Michael is taking over the maintenance of MoveIt. So how will be? How are you involved then for MoveIt? Will it be also?
So we're still involved. So me and Dave are still going to be involved. We just haven't had the time to do a lot of stuff. But hopefully, depending on how things work out over the next year, we can get back to contributing more over the next year. So we'll still do periodic maintenance, but it does help to have other members of the community helping us out.
Okay, sure. Thanks. Okay, we have one question from Kurt Webster to the DDF proposal. The issues that concern me, or Kurt, are captured very well in the asset community section on the page. Okay, yeah, that seems to be hard to answer maybe. The community should be aware of this. Arne, I'm not sure if you can answer this question.
Okay, let me reread the questions. Proposal and the one at the box is issues that concern me. Okay, so he makes reference to some issues that he has.
Yeah,
okay, I'm not aware of this on this post. Yeah, it's a statement like I think it's really a statement like Kurt added to his comment. I'm going to take a look on this. I don't know what the concerns is. I mean, I also have a concern in saying just because I don't know if this goes in the same direction, but perhaps it's worth mentioning this. Just using DDS doesn't mean that your system out of the box is real-time capable. I think this might be a misconception that many people associate with having DDS equal having real-time capabilities, because when you look into this implementation, ask the vendor, they say, okay, you can specify these QS temporal QoS, but since you need to, let's say, instrument the underlying hardware, or you need to do some network management. I mean, if you have a channel over a network, and the network, you have to configure the network somehow that you also get the transport priority. Same goes when you have, let's say, you want to receive or execute at a certain rate, then you have to instrument the operating system. I think this is perhaps something that we should keep in mind, and that when you have to map somehow some of these DDS properties also to the lower levels of execution and communication. I don't know if this goes in the direction, but there are some concerns and issues then. Yeah.
Maybe I can also give a short comment. I think Kurt's comment, as far as I read it, refers to the ethos of the difference between the companies providing DDS implementations and the way the ROS community works. So usually those companies are like, in the article it says like old school software engineering organizations. They are used to usually used to like closed source development, big projects, and a different development style, I would say, than the community in ROS. So that's a little bit different from like other projects. If you look at ZeroMQ, it's an openly developed project which has a much more vivid community. That's different for the DDS project currently. But maybe I can make a point why that might still be something that can change. We had in the last year really good conversations with some of these vendors, and they do see the need of a solution like DDS in the robotic world, and I think or we hope to get these communities to like get closer to each other, and in that process also for the DDS vendors to become a little bit more open and consider more like a community model where they make sharing of their open source version, for example, easier. Because sometimes it's like claimed to be an open source version, but you have to first register on a forum and download the version, where from our experience we tell them that that's something the ROS community wouldn't accept. If we claim to have an open source DDS implementation, you got to be able to download it without a registration, for example. But these things I think are hopefully details we can work out, and the current conversations we have with some of the bigger vendors are very promising. We'll see if we can have more updates on that in the near future, but yeah.
Okay, that's of course also an issue, yes. And also, it's not. I think I don't know if this is an advance. You already also mentioned that this standard is constantly developed further. I mean, currently there's also like query response, so which is not part of the standard. At least last time I checked, perhaps it. And they're currently working on this. And in the meantime, each of the vendors has its own implementation of.
Yeah. So the request response is actually a current proposal, which I am not sure if it has been ratified last month or will be ratified next month, but it's basically at the point that the big vendors, after having competing proposals in the beginning, now have like agreed on one. And some vendors already have an API which is almost compliant. And the nice thing is our abstraction layer can always work around those little details. But there are more proposals in line, for example, for security, which will be interesting for us too. But they are still need to be like agreed on and ratified. I think they're scheduled for like the summer or something this year.
Mm-hmm.
Okay, thank you for answering the question or the statement. The time actually is running out. I think there's a very quick question from Dustin Hallinger about the training in Peoria. I think that's very quickly to be answered by Paul.
Sure. So there's a stub on the ROS-Industrial.org website under events for the training, the upcoming training. So at this point, it's just kind of a save the date, and I'll be posting the kind of Google Maps information for the building here shortly. But the specifics of the course curriculum they still need to be hammered out a little bit. So I'd say just revisit that page in the next couple of weeks, and we should have that those details posted.
Okay, perfect. Thank you very much. If there's no more very urgent question, I would like to thank you, all the speakers, for their time, and all participants for being here. Also, Clay, again for hosting for doing the technic background. So very, very nice. Thank you very much. Just get tuned to ROS-Industrial and follow the next community meeting. Thank you very much.
Yeah, thanks for the organization.
Okay, bye-bye, everybody.
Bye.
Bye. Bye.
Bye.